What's up, everybody? I'm Maui13. Okay, I want to get right to the robot. Let's play the video and do the live commentary. Here we go. Okay, so immediately somebody was like, oh my god, it's all in 3D, it's Blender, it's fake, it's not real. Well, they've done a really good presentation. So, like, this is a lot of good ideas in this bot, and it's the shape of it. Let's let it play one more time. So what is this? The battery? Battery. I don't get the hip thing. Okay, so you got a little bit of rough grip tape on the hands. Really nice hands. Feet that look better than a lot of other robots. This is basically looking like sleek. I don't know. We wouldn't normally say sexy, but compared to the trash that you see out there, this is just such an attractive, a lot of nice contours without being overly fat in any particular place. So you think about a bot and you think about the utility you want it to be. You want to basically put it in a corner, put it in a tight spot when needed, and then look like it's not gonna get in the way. I guess it's just a mental thing. So let's jump over to their website. Is this thing going? Usually it's animating, so I don't know. Watch the video. Okay, I guess I should have done it here. Oh, is this something different? What do we got? Okay. Buffering. We're not. Okay. It's not exciting. Seems like the video's not loading. That's not exciting. Okay, well this little animation loaded, which is nice. Oh, stopped. We seem to be having, at least I have the page. Okay, so this is usually a really nice animation. I'll see if I can get that to load later. Let's get right to the next point here. So, is that showing okay? Yeah. So, the Fourier, the Fourier GR-1 is the name of this humanoid robot. Breaks new ground in humanoid robotics for practical applications. They're basically saying that this is it. He is him because it can practically do everything and go everywhere, and it has embodied AI. We'll get to that. But let's go according to their presentation. Versatile body structure. That's what they're saying. So it's supposed to be strong, and it's supposed to be able to do all these things. And it's supposed to be better than, what's out there, I guess, or what's presented usually. So let's see. Advanced motion control replicates human-like degrees of freedom. So you see that the way the joints are and stuff, that the degrees of free range, the degrees of motion, and that it's what we're seeking now in the robot world is to they're trying to be able to do the the human makes the motion, and then the robot does what the human is doing. So through this, they probably discovered, now something is loading, some music stuff is playing. Whatever, won't worry about that. But they probably discovered that the robot was having issues doing the same thing that the human was doing. So then they went back to the drawing board, so to speak, and tried to give it its free range so that it could replicate what the human is doing. And then it's like, oh wow, what a concept. Make the robot able to perform what the human... Well, obviously in the beginning they weren't doing this, but now they realize that you can train. You can train the machine learning, you can train the AI. Okay. Where was I? So the physical dexterity speaks back to the body, not to harp on this, but this is the way they're presenting the website, and I'm just going to speak what needs to be said. Things maybe that haven't been mentioned, for example, the head movement. Even though, it was kind of implied that the head is not necessary or important,
But then we're realizing that, what do they think about it? They think about, we're going to get to see if, I haven't even gotten there. Okay, I'm going to jump down because we talk about the head. Look at what they're doing with the head and why they're equating it to human. And they're saying, look what you can do and how you can do it. And so what they have is the audio sensors for speech recognition. So they're trying to pick up the audio from the central point of the head or around the head. The visual sensors, cameras are happening in the head. Obviously, you can make a robot without a head or have the head just be a figure piece. But they're saying, look what we can do with it. A curved display that they're showing, you can do all sorts of output displays. That is the human interface. Humans like to see what's going on or what the robot can display or communicate non-verbally. It might just say okay on its face if you're like, hey, robot, I want you to be quiet. Know that it, and then it's going to say okay. And it's going to say question mark. I didn't fully understand what you said, right? Without actually saying anything. And maybe you're just trying to think and not listen to a stupid robot, right? So they're saying that there's something important about the head. And then the speaker, so it can output clear and crisp audio and all these types of things. So it's compelling, yes? So we can jump right back. I want to stay on point and go down. Okay, so they're basically saying, look at our stuff. We have the ability to do these human-like movements, for example, the waist movement, and we see why that's important. You see that they have a good demonstration of the twist of the where the waist is moving. 360-degree observation while standing. Okay, so so they're saying that it can rotate around and it can stay in place, but it can look everywhere, I guess, is what they're trying to say. There's a lot of compelling setup here. The reason I jumped on this is because it's a very good... There's a lot going on, and it's very compelling. And even though there's a lot of 3D here, yes, we will realize we're not looking at physical, actual prototype robots here. We're just saying, well, they did a very compelling presentation. We trust it as we go. So, of course, Elon Musk and Tesla have, they believe that they need the arms and hands to do all these things. And then you see that they're having robots fold clothes and do delicate tasks and have sensors on their fingers and hands. And then, basically, they're saying, check the hand specifically, human-like hand design for versatile forms of manipulation. And so that's basically, we believe that's important because that's what people want. They want work, home, and hybrid. They want a robot to be able to do anything, quote unquote, and they believe it should be able to go above and beyond what we generally think. Like, it should be able, it could just lift those boxes, but come over and make some tea. Because it's the whims of the people. They're like going to say, well, why do we have robots if they cannot do better than humans can do? And, that kind of thing. So we're really demanding. But we're going into the future. It goes to show you that we are going into the future and people start demanding what we've been dreaming up. We have the technology, we have the software, we have the brilliant minds, we have the competition. It's the reason why we're going to be paying money, because we want the best that can be given to us and sold. It's a product, right? So then you have, of course, the users demand a good product, and at least you create standards. So let's look at their balancing algorithms. So we talked about how it has a system for walking and a system for balancing. Let's see if they say anything compelling here, additional information. Of course, it's not assisted, and they're trying to highlight that, even with a complicated environment, that it can manage it. It maintains a dynamic equilibrium. Of course, none of these things are going to be automatic and expected. They're saying, look, we created this system, we tested it, we offer this system. It's a feature. We're not saying the robot is just going to be able to walk and balance as a byproduct, or you know, if they highlight it, that means that they spent a lot of time working on it and they want to sell that aspect of it. And they say it's important for a robot, which it is. Depth camera, so we already talked about all that kind of stuff. Can walk stable on terrains like gravel and grass, which is really getting more into the nitty gritty. You know, you don't want a robot that can only walk on hardwood floors or concrete floors. You need it to not mess up when it walks on unusual surfaces. According, you know, it's going to be obviously really unusual for a robot when, you know, they test largely on a stable, flat ground with no small pebbles or anything to throw off, so that they can, you know, get to that level where let's figure out walking on a solid ground before we get to gravel, sand, grass, dirt, whatever. Adapting. Traverse slope with straight legs. Well, that's quite a complex thing that they're showing there. I don't know about all that, but they seem to be indicating that the robot is balancing and has the strength to, as you can see, it's supporting the weight on this foot that has, obviously with the hinge system, the thickness of the material and the advanced design of the material, and then you have this kind of system to move the foot angle, which has enough strength in it to be able to support it. In this particular example, you know, the foot is not being the foot angle is not changing even when it's just focused on that one point. So that's a promising design if this is true to the image. Then they're saying withstanding external forces and avoid falling over. So this is saying that the robot can continue to calculate and counter the forces being applied to it. And they seem to be indicating that it can do that with a lot of weight. So that would be a great thing to see in real life, to see the consistency of that. Offline motion library. So we talk about how they seem to be indicating what you might think or might not have thought of, is that these robots will be connected to the internet probably for cloud computing, probably for processing of information. But they're trying to indicate that you have an onboard system that works without internet, so that you never have an issue with its core things. A motion library is inside the system, inside the robot. And so, of course, you have all the usual stuff. Apparently, they're indicating here the connection is that you have an offline motion library for object manipulation, walking, and all the balancing. So the one that impresses me a lot more is the object manipulation. Makes you wonder how much offline capability is in the object manipulation. But of course, they just seem to first walk before they run, no pun intended, to have it, you know, move things, grab things, that kind of thing. We're not seeing an extremely advanced set there, but how much more could it offer if it's upgraded and enhanced through internet and updates? And so, you know, you have the question of, well, how much more can you load in the offline system, right? Can they actually perform, give it a new set of things it can do, or, you know, a subset, like, you know, okay, it could grab objects previously, but now it can, I don't know, it can do more. So let's see here. Walking with human-like gait, wider field of view, and low power consumption. Okay, this is important stuff. They're saying that simulating the natural gaits of human beings, obviously you want a wide field of view, and that's where, so they're saying, you know, because I've talked about this before, that they have their camera systems that they believe in, that they're going forward with. You know, usually a robot has a camera not usually, but anyway, the solution that they found is to have a camera facing down as well as forward, because they can see, they don't need to see like a human with only two eyes and only what's in front of them. If they can see everything that they're working with in front of them, which is important, they're trying to say that maybe perhaps you can accomplish this with their camera system, so that it can keep track of what's going on what it's doing with its hands, while at the same time keeping track if somebody's approaching or talking to them, or something is happening in the peripheral. So there's possibilities like that. Let's see here. Typical stuff here. Advanced but typical. 32 high-performance FSA actuators. Of course, we're not doing hydraulics. We're doing motor, driver, reducer, encoder. Torque, high torque with electric motors. Precise control of intensity and accuracy of movements. And the smoothness, that's what we would expect. Then we go back to the visual environmental perception. Grasping. The vision algorithms, rapidly identifying different objects. This is one here, object manipulation with their perception. This is the object is identified, and this is a representation of what how the AI is interpreting the object, and then the robot physical interface, which is the hand, is going to actually grab it or manipulate it. So that's their solid foundation. It seems obvious, but that's like what they're doing. They're showing you that, they're applying really everything that we learned and know and think how it should be done. They're applying it. They're doing it. So there's a lot of confidence here, because it's point after point after point, very competent, a scientific approach. They're not trying to reinvent the wheel. They are trying to refine the wheel. So that's good. And then the open source app code, underlying SDK, which is the programming toolkit, if you don't know that. Basic pre-programmed large language model AI. The arrival of embodied AI, offering global developers the opportunity to innovate together in AI and robotics. So they're saying that it's not only the company that is going to be offering things for the robot, but the public developers and these types of things. So that means you don't have to wait for an update for a robot to do something. So, I mean, that's a promising concept, to open it up. A lot of companies will say, no, we have to handle everything. We don't give the user any capability and in fact, our policies are not to do that. And we don't even facilitate a way to do that. And we don't even tell you what kind of software we're using or anything like that. So, that is going to be understandable in the robot world. You're going to have the full spectrum. But this is one of the few and that are sophisticated that seems to be offering. What we're looking at here, multi-device control app smart interaction. So basically, motion control, high-definition video transmission to your mobile phone. So we're talking about security systems and monitoring, knowing what's going on at home or the work site by tapping into the robot. Some kind of manual control, possibly initiating tasks and things remotely. Have fun controlling the GR-1. Of course, it's entertaining, right, to control your robot with a remote control, quote unquote. So they see that people would like that instead of, let's say you had a robot that was like an AI robot, and then the only thing you could do is give it voice commands. Or the only thing you could do, which is not, that you would type in on your computer what to do and then the robot would do it. It's like not limiting, but instead the other way, opening it up. Well, why don't you, let's give them a way to use their smartphone to control the robot and then talk to the robot, and then, if you want to send an email or a text message to the robot, why not, right? And have all those things. So let's see. I haven't looked at this particular area here. Sorry that the video is long, but they put a lot of content. So they're saying, all right, well, it's important to note, because you cannot assume any of this, right? They say widespread commercial adoption. They say scenarios ranging from concierge, guidance to security and inspection, manufacturing to healthcare and rehabilitation, research and education, and, of course, household service. So they're saying we want it all. We're targeting all the things where money is. We're going after the money, and that's makes business sense. So of course they're trying to show that what it can do here, and then manufacturing. Robots making robots alert. I think they're saying manufacturing, and then they show the robot taking a hand and an arm and a, you know, a part of the robot, and then they're saying, okay, well, I guess we could do some assembly here, and so that's a very interesting little point there. Maybe it's kind of an Easter egg, or maybe it's just saying, why can't the robot make the robot? So that means that the versatility, the robot should be able to make a robot as well as it should be able to work on a car manufacturing line, or, you know, whatever, putting away your groceries. I don't know. So anyway, let's see here. Rehabilitation, medical. So they're saying how they can deploy it and use it for, you know, helping people that need, you know, various, you know, interactions or rehabilitations. And then they're saying it's working with doctors and, you know, people that, you know, work with humans so they can help them. So you have an assistant and all these kinds of things. Let's see here. Start the era of embodied intelligence now. So the one thing, let's see if this video here, let me go ahead and unmute here. I really like this video. It's going to loop a little bit. Let's watch it. So you're seeing stuff. Obviously, it's the looks like a battery indicator. Well, it did have a battery indicator on the battery. This might be hard to say. To me, it says full low battery. Obviously, a preview of the screen, which is nice, legible, futuristic. The hands. I noticed a difference with the hands. I think that there's like two versions of the hands presented. So I'm not sure. It's likely that this is a bit of an older design. It's likely that the hands that we saw in the beginning are the probably more the modern final hands. Even though those don't look bad, it just seems to be more in line with what we're currently doing with the hands. More applicable to everything, or it could just be that you can swap the hands out. And I mean, I'm saying you can, but it could just meet. But it's interesting that the hands, if I look at the hands here, the hands and the wrists seem to be connected there. And so the wrist, you notice that I'm noticing a key thing here, that it doesn't actually have a wrist part. It actually, the wrist goes higher up to the lower of the forearm area, and that part can move there. So I'm noticing that, and I think I want to jump back to the old video here. Interestingly, so, you know, that's the thing about this 3D design and stuff like this. If you look at the hand here, okay, maybe this, I mean, this seems more advanced. You see a wrist, right at the wrist. You see the rotation point. Robust, but able to be moved. And so you see that the wrist, the hand rotates like left and right. At the same time, it can bend its wrist forward and backwards. So this range of motion makes more sense. This, to me, says that this is a more advanced design, and probably what the product release will be. So that just tells me everything, because you need that. You want that. You need that. So I'm already noticing that that's the way. You can see that it moves like a human. If you imagine it was just a human doing that motion. So it just makes sense. You cannot lock the wrists like that. Unless you want a Mr. Roboto Domo Arigato. Thanks for watching. Hope you subscribe. Most people aren't that come across my videos. Hit like if you liked it, dislike if you didn't like something about it. I'd love you to interact on the comments. I check it out as much as I can. Every day I post Twitter for AI, robotics, and technology news. So follow me on there if you're not, because just take a second and do it. Growing my channel to 1,000 subscribers on YouTube. We're marching forward just like this robot is. So thanks for watching again. We will see you on the next one. Anytime there's something significant, I am prompted to act and post, talk about it, show the videos, show the high resolution images, give you the data. I'm a very science-like person, so I like to present things concise. I don't like to make things longer. I just end up sometimes speaking in a long format. So I hope that you do not mind that. Thank you for listening. If you made it all the way to the end, you're amazing. Have a great day.